All right.
Look at how cute that is. I think we should like put this in there and like hit it.
Where'd it go? Oh.
Okay. What is that? What is it?
It's not worth it. It's not worth it, man.
Ready?
It's not Anderson.
What?
You got out of Anderson. Did you hear that? Sure.
What did he say?
Choosing not to respond.
There we go. Hit it.
All right.
Well, I scared
Let's go ahead and begin. All right. Today we're going to start by talking about something called the residuals. The residuals are if we have a scatter plot and we find our least squares regression line that goes through there. The residuals are the difference between what the line would predict and what the actual is. So we actually kind of talked about these yesterday, and we said that what the least squares line does is tries to make the square of all of these things as small as possible. Okay? And it would take all of those distances and square them, and it's going to try to minimize that to find our least squares regression line. Those distances are called the residuals. If we do a plot of the residuals and their distance away from our line, you're going to end up with some of them above because some of them are above our line, and you're going to end up with some of them below. And if that line actually goes through any points, then you might have some that are actually on the line. Okay? But what we're showing is that some of our points are higher than our line and some of our points are lower than our line. The average of those residuals, if we actually took all those measurements and found the average there, the average, the mean, would always be 0. A residual plot, it says, is a scatter plot of the regression that can help us see how good of a fit the regression is. If it's a really good fit, those residuals should be small. They should all be very close to our line. Okay. We talked about how our least squares line is not resistant because it's based on standard deviations and means, which are not resistant to outliers. So if I have a data set and let's see, I'm looking at page 130, so I'm just kind of trying to copy what I see there. We've got this kind of picture, and we've got our regression line coming in. That one point way over looks like it might be a little bit of an outlier. Everything else kind of clumped together, and then that guy's all the way over on the side by himself. If we take that out, then this regression line moves a little bit. And it becomes a little bit lower. So that point was kind of pulling that regression line up a little bit. It didn't make a huge change, but it just made a little bit of a change. If we take this outlier and we actually make it like a crazy outlier, like move it so he's all the way down here, it will actually change the direction of the regression line. So one point can have a significant effect on what happens to your regression line. So outliers are a really bad thing for regressions. Okay, just like they were for means and standard deviations, because regression lines are based off of means and standard deviations. So they are not at all resistant to an outlier. Okay, and then the last thing we need to talk about is some cautions about using regressions. The first caution is we should only use them for linear relationships. Okay, we're only going to do linear relationships for these. So if our graph has any sort of curve, we don't want to talk about correlation, and we wouldn't want to find a linear regression line because our graph isn't in a line. The second caution is what we were just talking about, that they're not resistant. So check out your data and see if it looks like there's any outliers, because if so, they're probably having a big effect on what you're getting. The third caution I mentioned yesterday, but to beware of what's called extrapolation. And that's trying to make a prediction that's outside the realm of normal. Okay? So let's say that I did a plot of, I don't know, I'm thinking about height, I don't know why, but like age and height up until like age 16, okay? And it probably, this isn't a linear relationship, but we'll pretend like it is. I could use this to maybe predict how tall. I could definitely do anything within here. Like, let's say I was measuring my kid every year and I forgot to measure him a year, okay? I could use this to predict how tall they were that year, okay? At any point within. We call that interpolation. That's finding a prediction within our data. When we go outside of our data, that's called extrapolation. So then I'm wondering, how old will they be when they're, say, 25? Probably not a great idea, because their growth pattern could change. Definitely not a good idea to guess how tall they're going to be when they're 40 by this pattern. Okay, we would have giants. Okay, so to predict outside of our data range, if we get very far outside, we need to be really cautious about that, because data patterns can change quickly and change drastically. And our last caution is something that I hope you take away from this class as a big, big, big idea, and it is to beware of the lurking variable. The lurking variable, defined here, says it may explain a relationship between the other two variables. So when we have a really high correlation value and a really strong regression line, something within us wants to say that one of those things caused the other one to happen, which is not necessarily the truth. There could be something else that caused both of those things to happen. So for example, in the notes, example 7 says, the Kalamazoo, Michigan Symphony once advertised a Mozart for Minors program with this statement. Question, which student scored 51 points higher in verbal scores and 39 points higher in math? Answer, the students who had experience in music. Okay. It probably isn't the fact that they play music that made them do well on their verbal and their math. Okay? It's probably more of a socioeconomic thing. That kids who are involved in higher music programs often come from a higher socioeconomic class, often have parents who are more involved in their children's life and extracurriculars, and then would also be involved in their academics. So there's probably something else happening there that made both of those things happen. It's probably not studying music that actually makes you score better on a test. Okay? There could have been something else there. I mentioned earlier this year that example of shoe size and reading score. Because you have bigger feet, it's not going to make you a better reader. Both of those things are caused by age. Okay? So looking for what might be happening behind the scenes that's creating that cause relationship. So one phrase that we use in statistics is association does not imply causation. So just because two things are associated with each other, that they have a relationship, that doesn't mean one of them caused the other one to happen. Okay. And that is the end. There are some more examples in the book, kind of listed in like example 8, 9, and 10 that you could look at that have some examples of things that might be associated but not caused by each other, but they're not problems. It would just be like a little story to read through. So I'm not going to read to you here, but if you wanted to look at examples 8, 9, and 10, those would have some more examples on associations that don't necessarily show a cause-effect relationship. The weather is such a problem.
They were telling me on the radio that
They were telling you.
They
were telling me on the radio.
They were talking specifically to me.
Right?
I heard on the radio that it was supposed to rain, and a little bit here and like
Right.
a whole bunch in
Yeah,
Kalamazoo and stuff like that. Which I think is
That's why
pretty
that
nice.
light is out. Yesterday I was sitting in here grading papers at like 4:45, and all of a sudden it sounded like somebody turned on a faucet in the ceiling. I was like,
From Sam's Club.
so I called Mr. Brewster and I'm like, I don't want my ceiling to collapse. So I don't know if it actually broke the light or if he just disconnected the light because it's dripping right by the light. It's also dripping right by the Apple TV projector. He has a bucket up there to try to catch the leak until it gets fixed. There's no point in fixing it now. I just kind of waited out through spring.
Yeah.
But yeah, I always have problems there and there every year by my projector and by my screen.
Yeah, but
I'm like literally
two
those
water
are like
spots there.
yeah.
Yeah, weird. You think that they'd fix it?
They've tried so many times. They can't find where it's coming in. Like they can't find a problem with the roof to fix. Like the roof looks fine, but I still end up with water in my room. Last year I actually had a puddle in my room one day. Like a desk was covered in water.
Yeah, you didn't like see anything dripping.
Well, the whole ceiling tile, and like so we can see a drip coming from the ceiling to here, and obviously it must be coming from the roof to the ceiling, but they can't find where it's coming in the roof.
Yeah. Weird.
Yeah. Mason was supposed to leave on a flight at noon today to Minneapolis, and they're supposed to have a big storm. And so last night at like 8 o'clock, they canceled his flight because they were supposed to have a storm.
And they didn't.
And they rescheduled him for a flight at 6 p.m. Then the storm is apparently running late, so they canceled his 6 p.m. flight. The noon would have been fine, but they had already canceled it. So now he doesn't get to leave until tomorrow morning.
And then the storm probably would already be happening, and
Right. So then, like, are the runways clear? And because they're supposed to get like 6 to 9 inches tonight, I think, in Minneapolis.
I'm going to the Jason Property concert.
So you want
weather
And then to Applebee's.
is ridiculous.
Yes, you're basically.
You hate rain?
Right
now because it's ruining snow.
What?
Cause like I was going to go yesterday, and then
Oh.
and then no, I can't. How can I so boring? 'Cause you don't do no, it's not
I
as
think
fun.
that's like the
It's not as
exact
scenic.
opposite as anyone else.
It's not as scenic. It's fun.
Yeah.
Go up.
Little sideway things.
You want to see.
Fly in the air on a little
They wanna go sit, they wanna go slide.